Okay, so now we're going to continue to analyze arguments. So far we talked about analyzing an argument using an Euler diagram. Now we're going to talk about analyzing an argument or seeing if a conclusion is valid using a truth table. So how do we do that? Okay. Well, so imagine that we have, let me close this out for a sec. So suppose you're being asked to evaluate the argument n or q, not n, therefore the conclusion is q. Okay. So first of all, is this little statement or argument valid? Yeah. In fact, this is a law. Which law is this? Right. So if you can remember the disjunction part, that's good. The disjunctive syllogism. Okay. Okay. So here's the thing. So this argument saying n or q, not n, therefore q, is the same as writing it like this. So we've compressed everything into one logical statement. Now why is this equivalent? Well, what do we have in this statement? We've got n or q. Well, yes, but one thing at a time. First, let's see why the translation is correct before we say does it work. So notice that we've got the n or q is n or q. Then no, that's not what I want. Then you've also got not n, not n. Now notice that when you list things that you know, that's like saying and. You're saying I know n or q and I know not n. So we have an and in there. And conclusion q. Well, logically speaking, what is that the same as saying? That's the same as saying if you know these things, then you know q. So that's why making an argument the way that we've been making it so far is this can be expressed as an if-then statement. Does that make sense? Okay, good. So once we know that we can take an argument with a conclusion and translate it into an if-then statement, how can we then use that to analyze whether or not the argument itself that we started with, whether or not that's valid? Well, for an argument to be valid, that is the same as saying that the if-then statement is always true. So in other words, is this argument valid is the same as saying if we know this, then we know this. So if the if-then statement is always true, then the argument is also proper or valid. Another way to think of this is to say, what would make how could we know that the argument was invalid? Well, the argument would be invalid if n or q was true and not n was q, but q was false. If that's possible, then the argument can't be valid. Right? If it's possible to know all those things, but the conclusion isn't true, if that's possible, then the argument is not valid. Does that make sense? But that's the same as saying that we've got true, 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 but then a false. Notice how that translates into the if-then statement. You would have true, true, if true, 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 then false. What's the value of that? Right. We'd have an if true, then false, and that's false. So the if-then statement is false exactly when the argument itself is invalid. So now I know this muddies the waters a little bit because we just got through saying that a conclusion being true is not the same as the conclusion being valid. But notice that I'm not talking about the conclusion being true. I'm talking about the entire if-then statement being true. And these are very different things. We're not comparing the entire argument to the conclusion. We're comparing the entire argument to an if-then statement. Okay. So let's actually work through this and work through the example, and then we'll see how this goes. Okay. So I've prearranged the table with all the necessary headings. So let's fill it out. Okay. So again, how many variables do we have? We have 2, n and q. And so how many rows is that going to give us? 2 times 2, it's going to give us 4. Okay. Or 2 to the second. Okay. So what are the 4 different rows? How do they start? The first one is true, true, and then true, false, and then false, true, and then false, false. Okay. So now let's fill in not n. So how does not n go? False. Okay. So actually, to fill in not n, we can actually do the entire column really quickly. So n is true, true, false, false. So not n is false, false, true, true. That was quick. So okay, now let's go ahead. So in the first row, what is n or q? True. Okay. Now what is n or q and not n? Well, n or q was, in the first row, is true. Not n is false. So if you do and, what is it? False. Okay. So now let's evaluate the if-then statement. Blah, 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 then if blah, 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 then q. Oh, what is that? What are the values? If what, then what? If false, then true. And what's the value of that? That's true. Okay. Next row, what's the value of n or q? Yeah, you've got true or false, so that's true. And what about the next one? N or q and not n? Yeah, it's because it's false. Sorry, it's true and false, so that's false. So now what's the value of the if-then statement? Because it's if what, then what? If false, then check the values. It's if false, then false. And what's the value of that? If false, then false is true. I don't. What do you mean? What's your question?
Like, are we checking not n or n or q?
We're checking. We're evaluating each statement. Okay. So in the next row, n or q is what values? It's false or true, which makes it true. Okay, next. N or Q and not N. So what values are that? Right, because it's what? It's true and true, so it's true. Okay. Now what about the conditional statements? It's if what, then what? If true, then true, which is true. Okay. Next. N or Q is right. It's what or what, which gives you it's false or false, which gives you false or false. False or false is false.
False and false is true.
No.
What did you say the last time? False is true.
If false, then false.
Oh, okay.
That's true.
So false or false is false.
Okay. Next. N or Q and not N is what values is that? It's false and true, which gives you false and true gives you false. So finally, we've got the conditional. It's if what, then what? If false, then false, which is true. Okay, right. So first of all, you notice that the conditional statement is always true, so it's a tautology. That's the first thing. The second thing is, once we know that the if-then statement is always true, what does that tell you about the original argument? The original argument is valid. Or in other words, saying that from N or Q and not N, you can conclude true, that's a valid argument. So, the if-then statement is a tautology, and then we can also see this tells us that the argument is valid. Okay. Sorry? Exactly. Okay. Here. Oh. Okay. So here's another one. See if this is a valid argument using a truth table. If P then Q, if P then not Q. Therefore, not P. Okay. So how can we build up a truth table in order to judge this argument? Okay. So to be sure, we're going to need P. We're going to need Q. What else will we need? Not Q. We will need not P. I'll put that at the end though. So what else do we need? Okay. Now we need some other stuff. In particular, how do we translate this argument into a logic statement?
If P then Q from parentheses.
Okay. P then Q.
And
Is it and or? If you're making a list of statements, do you use an and or an or? And, because you're saying that all of them are true.
and
Okay.
P or not P. If P then not Q. And then you put the arrow, then not
not P, but yeah. And let me just put big brackets around this part so to make it clear. Right. That's the same. I'm sorry?
That's the expression of what's in yours.
It's the expression of the argument. We've translated the entire argument into a logic statement. Okay. Now, that's the logic statement we have to evaluate. We still don't have all the columns that we need in the truth table. What other columns do we need?
P then Q, P is P then Q, and Q is P then not Q.
So, we still, I'm sorry, again, we still need?
P is P then Q, and Q then not Q.
Okay, right, so if we need this and that, then first we need the individual statements. So we need if P then Q, we're going to need if P then not Q. Oh, right, sorry. Crikey. Okay, right, so we're going to need this and P then not Q. Okay. And then finally, what do we need? We need the whole thing. Okay. So let's take this. There we go. Okay. Now, how many variables do we have? 2. So how many lines are we going to have? 4. 1, 2, 3, 4. Okay, so let's go to work. So how do we start all of the, how do we start the 4 rows? True, 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 false, false, true, false, false. Okay, next. Not Q. Again, not Q is an easy one. I like to fill in just the whole column. What is it? Right. That one's easy. Alright. And you know what? Not P is also going to be easy, so let's fill that one in too. False, false, true, true. Okay. Now what about if P then Q? Okay. If true then true gives true. Next. If true then false gives false. Next, if false then true, true. If false then false, true. Okay. Next, if P then not Q. If true then false, false. If true then true. If false then false. And if false then true. True. Okay. So notice that sometimes it's easiest just to do one column at a time. Okay, next. If P then Q and if P then not Q. Okay. So in the first case that gives you true and false, which is false. Next you have false and true, false. True and true, true and true, true. Okay. Finally, if blah then not P. So what does that give us? If false then false, which is true. Next, if false then false. Next, if true, then true. Next, if true, then true. So there you go. So the conditional is always true, so that tells us that our original argument was valid. Or again, in other words, you can always say that if you know if P then Q and if P then not Q, then you can conclude not P. Keep in mind, always keep in the back of your mind what it means to translate an argument into an if-then statement. It says, if you know all those things, then you can conclude whatever it is. In this case, not P. Dig? Def gonna need some more room here. Okay. The law of transitivity. What is the law of transitivity? That's the first thing. Anybody what's law of transitivity? Uh-huh. Uh-huh. Right. There you go. Okay. So this is the law of transitivity. Now, let's show that this is valid using a truth table. Okay. So, first off, what are the variables? P, Q, and R. So how many lines is the table going to have?
8.
Right, why? Right. 2 cubed, or 2 times 2 times 2. Remember, 2 values for P, 2 values for Q, 2 values for R. 2 times 2 times 2. 8 lines. Alright. So, 1, 2, 3, 4, 5, 6, 7. I need one more line here. Okay, so we've got PQR. What other statements do we need here? Okay, we're going to need if P then Q. What else? If Q then R. And what else do we need?
P then Q and Q then.
Okay. So we're actually going to need both of these things. We're going to need if P then Q and if Q then R. And then what other statement do we need? No, we're missing one thing. Right. We're going to need if P then R. And now we can write down the whole thing. Because the whole thing is if P then Q and if Q then R, then if P then R. Okay. So and again, when you construct these truth tables for yourself, you're probably going to want to write out the argument as an if-then statement first to help you construct the truth table from scratch. So write down that first, knowing that that's your last column, and then say what piece, and then to help remind yourself what pieces do you need. It's just a recommendation. Okay. So let's get to work. We got 8 lines. The first line is going to start how? True, true, true. Okay, next line. True, true, false. Next line. True, false, true. Next line. True, false, false. Excellent. Next line. False, true, true. Next. False, true, false. Next. False, false, true. Next. False, false, false. Okay. Now, I see that, well, a lot of our truth tables have 2 variables and 4 lines simply because it's got 4 rows and that's like more manageable. But occasionally, yes, you have to do one that's got 3 variables, it's going to have 8 lines. So then the question becomes, how do those lines start? I noticed that some people were understanding that, but let's talk about this. Notice that what you have is what's the pattern in a 4-line truth table? It looks like this. Well, what do we have in an 8-line truth table? You've got the 4-line truth table pattern repeated twice. Why is it repeated twice? What's happening in the first column? It's like, sorry? Well, what's happening in the first column? Right. You have to do the entire 4-line table, but first with the first column all true, and then you do it again with the first column all false. So if you weren't catching on how to organize these 8-line truth tables, this is the way that it makes sense. Okay. Next. Okay. If P then Q is what in terms of values? If what then what? If true then true, which is true. Alright. Let's do columns. I think by now we realize that just doing it column by column is easier. Okay. Until now, I did it let's go across, so you would keep in mind that we're evaluating certain statements. But now I hope and imagine that by now you sort of understand what the truth table is doing, and you realize that in terms of mental organization, it's quicker just to go by column. Okay. So, let's do it the quick way. If true then true is true. If true then false, false. If true then false is false. If false then true. If false then true. False. If false then false. If false then false. True. Okay. Next, if Q then R. If true then true. And what's the next one? Which is? Okay. Next is? Okay. So now we have to evaluate the AND statement. So what does that give us? Okay. So we're just doing AND on the previous 2 columns. Okay. Now we've got to do if P then R, so we've got to go back to the first and third columns on the table. So if P then R, in the first row that gives us if true then true, which is true, and next we have, well, okay, it's if true then false, which is false, then we have if true then true, which is true, if true then false, which is false, then and finally, let's evaluate the entire, the whole argument. If that whole thing, then if P then R. Okay, we've got if true then true, which is true. Then we've got if false then false, if false then true, if false then false, if true then true, if false then true, true then true, if true then true. There you go. Yep. Okay. All right. In the interest of time, I'm going to skip the next example, and if we have time, we'll come back to it. So, any questions on how this works? Aside from why does it have to take so long?
This is just to see the validity of the statement, right?
Validity of the arguments.
Of the argument.
Yeah. You have an argument, and you convert it into an if-then statement, and then use the truth table. If the truth table gives you that it's a tautology, then you know that your original argument was valid. Okay. Next. Okay, so I'm sorry, any other questions about this? Okay. Next. See if a verbal argument is valid. Or similarly, write down a conclusion that's valid. Okay. So here's the first example I want to look at. If I am a man, then I am proud. If I am proud, then I will be humbled. Therefore, if I am a man, then I will be humbled. Okay, so actually let's do this. Who thinks this is valid? Who would say this is invalid? Okay. And who's waiting for me to say what it is? Right. Okay. So here's what we're going to do. How can we analyze this argument? Break it down and let's write this out. Exactly. Okay. So we're going to convert this into notation. And when you convert this into notation, the first thing we need to do is we need to say what represents what. So what's the first thing that we're going to represent? Okay. Right. So if I'm a man, then I am proud. How are we going to write that? Okay. So I like what Shaquille is doing, where we're going to use, don't automatically use P and Q, use letters that represent what you're talking about, because it's going to help you think about the problem. So, M, what does M represent? No. M represents I am a man. Well, you could say if man then proud, but that's a little weird. Okay. So now to begin, I'm gonna write out the entire thing. M is I am a man. So what's P? I am proud. And what else do we need to symbolize? Okay, so what's the letter for that? H. I guess I will be humbled. Okay. Now, now that we've got the letters, how can we write this out in terms of symbols? What's the first statement? If M, then P. Next. If P, then H. Now what? If M, then H. And in particular, that last statement is our conclusion. So how do we represent that? You draw a line. So, is that valid? This is the law of transitivity.
You know what I realized? If it's on like, if it's diagonal, and it's the same as the conclusion, then it's valid. Like how the M and the H is on the conclusion,
right.
But it's also diagonal.
Right, but this is precisely the law of transitivity. That's exactly what that is. This is valid. Okay. So notice that, well, as a mathematician, to me, all the words just get in the way. Right? I liked what Dustin said after I read it. Dustin's like, yeah, that's deep. So, sure, it's deep, but is it valid? And notice that to help us analyze the structure of the argument, at least certainly to me as a mathematician, it helps to write it out in the symbols. Because then you can clearly see all this is the law of transitivity. Okay. So let's keep going. Alright. My computer is working or it's in the repair shop. If my friend comes over, he fixes my computer. If he fixes my computer, it is not in the repair shop. My friend comes over. What is a valid conclusion? Yeah. So I heard two things, and those were both valid conclusions. Okay. Right. It's confusing. So what should we do? Break it down. Okay. So, what's the first thing we need to symbolize? Okay. So, my computer is working. So, W for working. Next. R for it's in the repair shop. Okay. What next? Okay, my friend comes over. What should we use for that? Okay. My friend comes over is F. And then, now what do we need? What statement? Yes. Because even though it doesn't say then, it says then. Right. Notice that actually first I want to write out these statements and then Dustin I'll talk more about your point. Okay. So what's the next statement we need to have here? Okay. We need he fixes my computer. Okay, and what letter should we use for that? C? Okay. Do we need to represent anything else, or is that it? Okay. Do we need something for it is not in the repair shop? No. Okay. So let's. Okay. So now. So I think we think we've got everything converted into letters. So let's start writing it out. If we miss something, then we'll add it in. Okay. So the first thing is, the first sentence is, my computer is working or it's in the repair shop. How do we write that down? W or R. Next, if my friend comes over, he fixes my computer.
F then C.
Right.
If F then C.
If F, then C. So, and this is something that Dustin said. What word is sort of missing? Then. But this is the English language. We understand that the then is really there. Okay, so this is where we really have to understand how to read English. I guess I'll just say that. Okay. Next, if he fixes my computer, it's not in the repair shop. If he fixes my computer, what's the letter for that?
C.
You guys chose it. Okay. C, then
Not R.
not R, exactly. Okay? And then what's the last statement? My friend comes over, so what does that tell us?
F.
Just F, yeah. It's just a simple statement. Okay. So now the question is, what is a valid conclusion? Okay. So we've got all these statements. How can we put them together and draw conclusions?
F then C then R.
Yeah, what conclusion can we make? We know these four things. So how can we put these together to draw a conclusion? Another way to say this, what two statements can we combine and use a rule of inference?
F then C then R.
Okay, so Terrell says, let's look at these two statements. If F then C, if C then not R. So what can we conclude from that? If F then not R. And what rule is that? Transitivity. There you go. Okay. So we take if F then C, C then not R. That gives F then not R. And that was by transitivity. Okay. So now we've got if F then not R. Great. So now what can we combine?
W or R.
And then F then R.
So you don't have to do this, but I'm going to rewrite everything just so you see what we have. We've got W or R. We've got F, and now we also just figured out F then not R. So what can we conclude from that? What two propositions can we combine? Which two statements?
F then not R.
Okay, if F then not R, along with okay, and how would those two combine? What rules do we know that we can apply? In general, you should be looking for propositions that have something in common. W or R and F then not R don't really have anything in common. One's got an R, one's got a not R, but usually you can't. Yeah. That's sometimes that works, but that's not going to work out here. So what two statements can we combine? Right, we know if F then not R, and we know F. So what can we conclude from that? If F, then not R. F. Therefore, we know F then not R, and we know F. So what can we conclude from that? We know F. If F, then not R. F. Therefore, we can conclude not R. What rule is this? If P, then Q. P. So what can you conclude? Q. It's the law of detachment. The names aren't that important right now. Right now it's more important for you to understand the logic. If it rains, then I will bring my umbrella. It rains. What can you conclude? Bring your umbrella. That's all that's saying. Or let's put it back in words. If F, then not R. If my friend comes over, then it's not in the repair shop. F. My friend comes over. It's not in the repair shop. Does that make sense? Okay. Well, that's all it's saying. So now we know not R. So let's sum up what we know. So now we know W or R, and we know not R. So what can we conclude? Now we can conclude W, absolutely. And what law was that? No. Yeah, it's the disjunctive syllogism is the name of it anyway. Okay, so there you go. Okay. So this was law of detachment, which is also known as modus ponens. Okay. And then this last one is using the law of disjunctive syllogism.
Are the online quizzes going to be like you give us a disjunctive?
The quizzes are going to be just like the homeworks.
So are they going to use these terms and stuff?
Might. Yes. Okay. So finally, what can we conclude? We've concluded W. And W is the same as saying my computer is working. So there you go. This is 3.6. All right. So this is how we look at the logical structure of arguments. Okay. So notice that you have to be at least a little familiar with, I'm going to say, the basic laws of inference that we've talked about. I gave you that list before. Let me flip back to it for a sec. There it is. Okay. So these are the 4 basic laws. I put in those other 2. The other 2 are pretty obvious. They might come up. You don't have to know the names, but these are the 4 main ones that you definitely should be using. Okay. Alright. So now we're going to bring everything full circle. We've got this argument. We're going to decide if this argument is valid. Let's check it out. If that tree is infested with pine bark beetles, then it will die. People plant trees on Arbor Day, and it will not die. Therefore, if people plant trees on Arbor Day, then that tree is not infested with pine bark beetles. Okay. Is it valid or invalid? So in order to analyze this, what we're going to do is we're going to make a truth table. So we're going to bring this full circle. We've talked about using a truth table. We've talked about converting an argument to symbols. And now we're going to do both. Okay? So let's check it out. So what's the first thing that we have to do?
You gotta break it down.
First we have to convert it to symbols, absolutely. Okay? So what do we have?
Pine bark infested.
Right. So we've got, it's infested with pine bark beetles. And what's the letter for that? I like I for infested. That's good. Okay, next. It will die. What letter should we use for that? D. Okay. Next. Okay. People plant trees on Arbor Day. A for Arbor Day. Okay. Is there anything else to symbolize? No, that's it. Okay. So we've got these 3 things. So we're going to make a truth table. How many lines will the truth table have? Oh. What's the symbol for it won't die? Not D. Okay. Okay. So how many variables? 3 variables. So we're going to have 8 lines. So as always, the first 3 columns will be I, D, A. Now, what else do we have? So actually, before we make the truth table, there's still, I think, some stuff that we should do. What do we need to do? Yeah, we need to rewrite the entire argument. We've got the symbols, now what's the argument? So what's the first statement? If it's infested, then it will die. If I, then D. Okay? Next. Okay. A. Oh, and. People plant trees on Arbor Day, and it will not die. Okay? Conclusion, therefore, if A, then not I. People plant trees, then it's not infested. Okay. actually, pop that up one. Okay. So now, so there is your argument. So now, let's set up the truth table. What are the columns of the truth table? IDA. Next. I then D. And now what? If we're going to do A and not D, technically what do we need first? We need not D. And A then not D. Okay. We're going to need not I. We're going to need A then not I. Okay. Now what else do we need? Before we do the whole thing, there's one more thing that we need.
I then D or then or A.
Gonna need more room. Okay. Okay. So we're also gonna need all the propositions as an and statement. So it's if I then D and A and not D. And then finally, we're gonna have the whole thing, for which I'll need more room. Which is going to be if I then D and A and not D, all of that, then if A then not I. Okay. And we need 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what are the rows? How do the rows start? False, 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 false. So this is going to be false, true, false. No. False, true, true. False, true, false. False, false, true. False, false, false. Okay. So if I then D is true then true, so it's true. Next. True then true, so it's true. Okay. Next, the column for not D. How does that go? Okay. Next, if A, then not D. This one says, what does the first one say? If true, then false. That's false. Next, if false, then false. That's true. If false, then true. I'm sorry, if true, then true. True. If false, then true. Okay, if true, then false. Okay. Next, what's the not I column go? False, false. Okay. And next, if A, then not I. If true, then false, so it's false. If true, then false, so it's false. If false, then false, that's true. True, then true, true. If false, then true, it's true. If true, then true, true. and if false then true is true. Okay. Now, if I then D, and if and A and not D. So, oh, I wrote it down wrong. Okay. So sorry. I got into the habit of writing all those conditionals. Nobody stopped me. This is an and. Okay, let's go back and do that column again, shall we? A and not D. True and false. False. False and false. False. True and true. True. False and true. False. True and false. False and false. True and true. False and true. Okay. This is now actually going to be correct. Okay. Next. If I then D and A and not D. So we've got to do the and of those two columns. False and false, which is false.
Everything is false except the second column.
Okay. And so finally, the whole thing. Okay, and what do we get? Wait, check it. Right, if false then false, so it's true. If false then true, so it's true. If false then false, true. If false then true, false then true. False then true. If true then true. If false then true. It is valid.
It is right backwards.
Yep. So this last argument, it doesn't sound right. I definitely grant you that. However, keep in mind how tricky it is. Remember how tricky conditionals are to begin with. So in this case, the conclusion is a conditional statement. So definitely, since conditionals are tricky, then making a if-then statement with the then part is an if-then statement is doubly tricky. So go slow. Have you ever read a legal contract? This is why lawyers need to understand these logical, the logical structure of arguments. It's because this is what the law deals with. This is what they deal with. Okay. Any questions?